Hi everyone, my name is Sachin and this is our health monitoring dashboard project. This project provides a real-time monitoring, analytics and alerting for a distributed system using a modern full-stack architecture. Let's quickly jump into a high-level overview. The backend is built with Python and Fast API, and we have used Prometheus, which is a fully open source software, and also we have used Prometheus for metrics collection and anomaly detection. The frontend is a React app styled with Tailwind CSS, providing a responsive and user-friendly interface. The system supports real-time anomaly detection, AI-powered log analysis, and we also have optional email alerting for critical issues. So as you can see, this is our main dashboard. Let me just quickly get the data. We have refreshed our data successfully and refreshed our dashboard. So this is our So this is the main dashboard, which gives us a quick overview of system health and key metrics. We can see the system health here, the Prometheus status, log status, and service status. As you can see, all of these system health are healthy, and this is the number of logs that we have emitted. So what we mean by logs is we have 3 microservices: order, catalog, and auth services. So we have tried to implement a real world authentication also. So we have tried implementing real world logging and registering. So we every time a user logs in, they'll get a authentication token. With that token, they can order, they can see they can check their orders, they can also view their inventory and stuff. So we have tried to mimic as close as possible to the real world environment. So coming close to the performance metrics, you can see the average latency, the percentile length of latency, and the total request, and the error rate. Also, these are this is a recent anomaly tab. If we encounter any anomalies, it will show the recent anomalies. As you can see, the high error rate detected. Service catalog service has high error rate 7 errors. Order service has 14 errors. So this is for error analysis. Here we understand what type of error: 404, 500 or failure. We have service error also, what specific service error and what are their numbers. And also here we have active anomaly bells. So this notification will get, if there is an anomaly, we'll get this notification, but as we have already checked the recent anomalies in here, we don't need to. So let's moving forward to the service health card. So as I have previously told you, these are all three of our services: auth, catalog, and order service. So for every service, we have uptime, the average latency, memory, CPU. So all of these 3 services are containerized. We have dockerized these 3 services. So every information such as memory or CPU is container specific. So we are scraping only container specific memory and CPU uses. And also we have a request, error rates, and how many errors are there. So this is the overview for service health cards. Now moving on to the log section. So here we can see our recent logs. They are all printed here. If we click on any log, we can understand and try to interpret more about this message, service, timestamp, level, status. We have also implemented the filter. Here we can filter any type of logs we want. We want error logs, we will have specific error logs. We'll have warning logs. Any services, if we have order services, warning logs. And also we have implemented different timelines also, like last 15 minutes. And then we can also automatic fetching of the logs. We can also close this, and it will not automatically fetch the logs, but if we start, as you can see, the logs are fetched automatically. We can also export these logs as a CSV file, as in here. You can see currently the logs are there. So these are all the warning specific order service warning logs which we have imported. And if so, this is our log consoling system. Moving forward, we have the metric section in which we are visualizing the data we currently possess. This is HTTP request, error rate, average response time, active services, and here we can select the time window. Let's go for last 1 hour, and here we can select the intervals. So with this we can change this data. As you can see, the data is changed now. So it's like HTTP request over time started at 329, the ending is 338, and this is the response time over time. So for every different time intervals and different time windows, we can select the visualization of our data. Moving forward, we have error rate over time also. For particular time, how much was the error rate, and here also you can see the window and the interval. So this is our response code distribution. So what's the distribution between different response codes? Success, how many was there? As you can see, this like detailed information, and also CPU causes. We can also so this CPU and memory is for the whole particular system. Earlier we had seen the continuous service specific, so this is for the whole particular system. Moving forward, we have Prometheus matrix. So as we have earlier told that we are using Prometheus for metric selection. So this is the scraping target from which we are scraping our matrix, and then these are the available metrics, and this is the metric summary. HTTP request, author times, how many tokens it has, how many DB operations it carried out, all of this information. So moving forward to our last tab, which is the advanced analytics with AI. So we have implemented AI. Currently we are using an LLM model called Grok. We have also used local LLM model Ollama, but here the request is specifically we are using Grok only. So when I run the run analysis part, it gives us the overall summary, the notable trends or patterns, any recommendation it suggests, how we can optimize catalog service performance, how we can investigate error root cause. And there is one more thing, we can also export this AI analysis as an AI analysis part, and it will save onto our local system. And this is automatically running every 5 minutes. We have chosen an intervals of 5 minutes, so we can get the AI summary every time. So this is the service performance comparison between the latency and the error rate. As you can see, for catalog service it's very less because catalog mainly includes the inventory operation, but for auth services it's quite higher, as we have implemented real-time authentication and authorization. So sorry, authentication on my bad. That's why an order service also we have to pass through auth service first, then comes to order service. That's why there is also a big leap of latency. So this is the error distribution. As you can see, the number of 404 errors, percentage, auth failure errors, and HTTP errors. So this is again the service performance, providing the average latency for all the services. Here we come from response code distribution, how many were success, client error number, and here we have service health overview. For every particular service, we understand how many requests and error were there, and what was the average latency. So here we have planted recent error summary, which gets us a recent error. So this is our error anomaly timeline for every. So we have visualized this error anomaly timeline also. So moving forward, we also have implemented this dark mode toggle, which we click, the system goes into fully dark mode. So it's like more user-friendly interface. And also coming back to the normal mode, we have also implemented email alerts with SendGrid, but as it's all we have only considered that as an option because it's not open source and we have to buy API requests and all. That's why, but Still, if we try to implement email on Omni alerts, we can get alerts like this. As you can see, this is on my personal mail from a different mail. I've sent it via SendGrid. So as you can see, these are anomaly detected, higher rate. See dashboard for details. So these kinds of alerts also we can generate, but yeah, we have to implement a bit more of Slack/email alerts, which will we have to buy a plan and all. But at the free version, we can at least provide some basic information on. So thank you for listening until this point.